In this video, we'll be talking about the derived units. So let me first of all write it down. The topic today is derived units. So what are derived units? So the derived units are the units which are actually derived by the help of base units, which are 7 as specified by the International System of Units, which is SI, and they are known as the derived units. So the basic definition for it is the units that are derived by base units, and base there are only 7 base units as specified by the System International SI. So this is the definition for derived units. And also you can say that all the other units except for the 7 base units are all derived units, because as we know, in the previous videos we talked about supplementary units, but supplementary units were removed and they became part of derived units. And now there are only two main categories of units, which is base units and derived units. So actually, if the all the other units except for the 7 base units are all derived units. Now let's take three simple derived units here. Let's take three derived units, simple derived units. We will take area, we will take volume, and we will take speed. To prove the point how the units of derived units are derived. Now, in case for area, as we know that area is defined in terms of meter, and what is meter? It's the base unit. For so the units for area will be square meter, which is m squared. The same goes with volume. We know the volume is also presented in meter, in terms of meter, which is a base unit, and the unit for volume will be cubic meter or meter cube. And then we have speed. So in case for speed, we know the formula or the equation of speed, which is speed equal to distance divided by time. So there are two base units in the play here. Here, first of all, the upper one is distance, which is the length, by the way, and the base units for length is meter. And then we have time. Then second is the base unit for time. Then so we will have m by s, or you can say ms minus 1 meter per second. So the units for speed, which is a derived unit, will be meter per second, or ms minus 1. Now, although there are many derived units, there are a lot of derived units. I think, according to what I've done the research here, I think there are more than 100 derived unit. But there are 22 derived units. There are 22 in them that have special name and symbols assigned to them by the International System of Units, which also includes the two-dimensionless units of the supplementary units, which is radian and steradian. So out of all those derived units, there are 22 units that have special names and symbols. So 22 derived units have special name and symbol. So To give you an example of it, about this statement, that special about special name and symbol, let's take a derived unit. Let's take frequency. So we know the equation for frequency is frequency equal to 1 by time period. So what is time period? Period is the time period is second. The base unit for the time period is basically second. So we have 1 by s, which is s minus 1. So the unit for frequency, which is a derived frequency is a derived unit, the units for frequency will be s minus 1. But instead of using this unit, instead of writing 1 by s or s minus 1, we will write it as hertz, which will be, where do we write? I think, okay, I'm gonna write here. So it will be hertz, or the symbol will be hz. Let me just clarify. So this is hertz, which is the name written in full, which is full name, and here, which is the symbol. Oh, draw this the symbol, the arrow other way around, which is the symbol. Now just note here that when I have written the full name here, I've written all the letters of it in lowercase, while in case of a symbol I made the first letter uppercase, and then the afterwards letters will be or lowercase. Why is that? So there's a method for it in order to write derived units. So they are usually written in lowercase letters. No matter what derived unit is, at these 22 derived units, their special names and symbol will be named, whether you're writing its full name or a symbol. They will always will be lowercase letters. But there is an exception to it. The exception is if the unit is named after a scientist, then 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 when we will write the full name of it, the full name will be as it is in lowercase. But when we are trying to write the symbol of it, the first letter of that symbol will be capital. Here which is the hertz was named after a scientist, so that is why h is capital and z is lowercase. The same goes and the full name is always will be lowercase. Now as I think you can check on Wikipedia the all the other 22 derived units, which along with their special names and symbols. But here we will only talk about only 5 units, and if I'm gonna try to talk to you about 22 derived units, the video will become more lengthy. But mostly this video is about trying to prove the point to you, what are derived units and how we can derive the units for it. So I will only present you with only 5 derived units. Hopefully that would make sense of it. Now let's start with those derived units, and note the 5 derived units that I will derive the units from is from these 22 derived units. So let's name it down. The first will be force, whose unit also I will write it here, and when I'm trying to note down, I hope you can see the last point that I have mentioned. You can see what is going on here about the lowercase, about the full name and symbol. We have first unit I have written is force, Newton, N, work, joule, W, Oh, I'm sorry about it. I'm really sorry. It's not W, it's J, capital J. The next one that I was about to write was the W, which is for power, which is watt. W, capital W. And then we have pressure, Pascal. Then we'll have electric charge. Now, as I have written it, I think you have noticed this when I was writing their units, their special name and units, that that the symbol of them are all of their symbols are capital, which basically means that the units and that the name of the units were named after scientists. So that's why the symbols are capital. The case for pressure, here you can see P is capital, then afterwards the letters will be lowercase, which is P capital, A lowercase. So let's talk about it. Let's derive the units for it. And also note that force, work and power, these three are kind of the same. They have some extension to it. For example, first we're going to talk about force, and then work will be addition of another unit, and power will be addition of another unit. So they are just basically the extension of it. And Pascal and electric charge are way different derived units. So let's talk through it. This will make sense to you when I write down the units for it. Let's talk about force. So the unit of force was named after Sir Isaac Newton, which was named after Sir Isaac Newton. Okay, let's make a point here. Named Sir Isaac Newton. And their symbols are, the full name and symbol will be Newton and N. So I will I will write this note of in every derived unit we will discuss. The first I will write down its full name, and then will be its symbol of it. So the equation for force is, as you all know, force equal to mass times acceleration, which is ma. F equal to ma. So what is the units of it? So the SI base unit for mass is kilogram, right? So what is acceleration? Well, acceleration basically is, let me just explain it to you on the other side here. So what is acceleration? Well, acceleration is change of velocity by time. And so what is velocity? Well, velocity is distance divided by time, which is distance divided by time. So here we have distance divided by time, and time will go beneath it, and we will have time squared. Acceleration is equal to distance divided by time squared. So the base units of it will be m m by s squared, which is acceleration will be ms minus 2. So basically the equation, the units for acceleration is ms minus 2, so which will be kg m s minus 2, which is the units for force, and this whole unit will be recorded as Newton, not capital letter. Oh, okay. N will be capital, and its full name will be Newton. So the units of force is kilogram mass seconds power minus 2, and the whole unit's name will be capital N, Newton. So let's talk through work now. What is work? So the unit of work is joule, which was also named after a scientist named James Prescott Joule. So let me write it down. Named after James Prescott Joule. And the full name for the unit will be joule, and capital J for the symbol of it. So what is the equation for work? So the equation of work is given by work equal to force multiplied by displacement, which is F multiplied by displacement, W equal to Ft. So as we already know, this is the force, so the units of force are kg ms minus 2. So here we will have N, which is the symbol for it, N, and the displacement is the basically length, so meter is the base unit of it, and we will have m here, which is Newton meter. So work is equal to Newton meter. But if we want to break it down into its base units, then this will be as kilogram. The units for Newton are kg m s minus 2, and then we will have m, so this will become kg m squared s power minus 2. So even if we break it down into its base units, we can write it as its base units, but it's really easily we can easily write it as Newton meter. So I think I have run out of space here, so let me just wait do I write down then. Can I make a page here? Wait a second, guys. Oh yes, I can make it. Oh, thank God. Now we will have what we have discussed over here. We have work, and now we will discuss about power. Okay, okay. We have power. So what is power? Well, the unit for power is watt, which was named after James Watt. So the unit for power was named after James Watt, and its full name and symbol is watt, and its symbol is capital W. So what is the equation for power? Well, power is basically power equal to work divided by time. So as we have already discussed above here, oh, also I forgot to mention it. these units will be also recorded as joule, which is capital J. So even though you can write Newton meter, but it's more convenient to write joule J because it's the derived unit, is the unit symbol for work. So here we have work divided by time. Then we will have, oh, we have joule, which is capital J, per second, which is Js minus 1. Even if we break it down to its more fundamental, more base, make it the whole units, base units in terms of base units, then that will be, what was it, the for work is kg m squared s minus 2 will be, joule will be kg m squared s minus 2 dot s minus multiplied by, which is basically s minus 1 here. So this will be kg m squared s power minus 3, which is the units for power, and this will be equal to, this will be known as watt, W, given by capital W. And then we will have pressure. So this is the derived unit, that is pressure, is different from the three of the previous ones. So there are no relation to it except for only one here, which is the force. So what is pressure? So pressure was the name for the derived unit for, the name of the derived unit of for pressure was named after Blaise Pascal. So it was named Blaise Pascal, and his full name is written as Pascal and symbol as Pa. So what's the equation for pressure? Well, the equation for pressure is pressure equal to force by area. Force by area. So Pa equals, sorry about it, Pascal. So the force is Newton, and the area is m square meter, which is m square, which will be n m minus 2. And even if we break it down to its base units, then it will be, what was it, I think ms minus 2, which is it, dot multiplied by m minus 2. So this will basically cancel out one of them. So kg m minus 1 multiplied by s minus 2, which will be basically Pascal, which is the unit for pressure, Pa. So the unit for the Pascal is the unit for pressure, and if we break it down into its base unit, then these are the units for it, which is basically kg m minus 1 multiplied by s minus 2. Now we will have electric charge here. Again, I have run out of space here, but I think this will be enough because this is the last one, the fifth one. Then we have electric charge. So the unit of electric charge was named after Charles Augustin de Coulomb. Named after Charles Augustin de Coulomb, and it written in full is Coulomb and its symbol is capital C. So what is electric charge? What is the equation for electric charge here? So the equation for electric charge is charge equal to qt, q multiplied by t, with q is the charge and t is the time here. So this will be, so the base unit for q charge is ampere multiplied by s, which is the second the base unit for time, and we have as, and this will be the unit for electric charge, and its special name is coulomb, given by written by its symbol, which is capital C. So these are just 5 out of 22 units with special names and symbols that I have discussed, only 5 of it. So I think you have learned about how to derive the to convert the units into its base units, hence the derived units. And there are many more derived units other than these 22 units, and Wikipedia has made categories for most of the derived units, and these are some of them are, write it down, kinematics, not this, kinematics, which is kinematics, SI derived units, mechanical SI derived units, SI derived units, molar SI derived units, electromagnetic SI derived units, photometric SI derived units, SI derived units, and thermodynamic SI derived units. Thermodynamics SI derived units. So they are also, and even if these are categorized, there are also other units such as hour, liter, ton, and bar, and electron volt. So these are not actually SI derived units. These are not actually SI derived units, but they are widely used in with the SI units, in conjunction with the SI units. So I think this basically covers up the video. The derived units, how do we derive the derived units with the help of base units, and how the procedure of how we write the full name and symbol, why we write the first name capital, the first letter of the symbol capital. And I have gone through force, work, power, pressure, and electric charge in order to explain how we in order to explain the derived units, how derived units are derived with the base units. And I think that covers up the video. So I hope you have found this video informative, and if you do, then please like and subscribe to my channel and share it with everyone else. And if you have any questions related to this topic, then you can also comment on down on this video, and I will try to explain it to you. Guys. So thank you for watching this, guys, and I will see you in the next video. Thank you.